Good afternoon, everyone. We're going to try something a little bit different, and we are recording this meeting in advance. You might see that I have two small children who are going to not distract us today, they have promised. But all we're doing is really trying to finish up the rest of this packet today. So let's see how this goes. Hey, Bear, I'm in class. You have to be quiet, honey. Okay, please color. I love it. Okay, so we've been given this equation which relates the Richter energy number and the intensity of an earthquake. Really the ratio of I to I naught, where I naught is the minimum detectable intensity. So what's interesting here is that you never really solve for I, you often just solve for the ratio of I to I naught. Right, the Richter earthquake equation in exponential form will seen as it doesn't tell me what base, it is an implied base of 10. So really we end up with 10 to the R equals I over I naught. The atomic bomb tested on Bikini Atoll, by the way, for those of you SpongeBob SquarePants fans, you might notice a little relationship here and between the setting of the show. Had a Richter number of 5, and the Northridge earthquake in 1994 had a Richter number of 6.7. How many times more intense? So what I'm going to do is I'm going to say that 10 to the 5th equals the intensity of that Northridge quake, which, by the way, was my senior year over at Harvard Westlake, over I naught. And while I'm at it, 10 to the 6.7 equals which one? Oh, sorry, this one would be the Bikini one, and this one would be the Northridge one over I naught. I'm comparing one to the other. So really I've got this divided by that is equal to, so I naught over, guys, you gotta leave, you're too loud, equals that 10 to the 6.7. Oh, hey. All right, this is already going great. 1 second. Okay, baby's chucked 10 to the 6.7 over 10 to the 5th, which equals 10 to the 1.7. That is the ratio of those intensities. The earthquake that caused 2004 tsunami in the Indian Ocean had a Richter number of 9. How does that intensity of the earthquake compare to that of the atomic bomb? So let's cut to it, and we're really going to end up with 10 to the 9th over 10 to the 5th, which is 10 to the 4th, which is 10,000 times more powerful. Times more powerful. Recall that the energy E in ergs of the earthquake is actually given by this formula. How does the energy of the tsunami earthquake compare to the energy of the atomic bomb? So again, we can just plug those in. The energy of the tsunami, we are going to find by 0.4 plus 1.5. It had a Richter reading of, we're talking about the tsunami earthquake, had a Richter reading of 9 equals the log of E. So we can calculate this on 11.4, and that's big E. not log of e. So we can say 10 to the 11.4 plus 1.5 times 9 is equal to e. So second, 10 to the 11.4 plus 1.5 times 9. These calculators know order of operations. E is equal to 7.94 times 10 to the 24th. Do the same thing over here for the atomic bomb. Just change that 9 out for a 5. So 11.4 plus 1.5 times 5 equals the log of E for ergs. So 10 to the 11.4 plus 1.5 times 5 is equal to E. And again, 10 to the 11.4 plus 1.5 times 5. And now I'm going to get a 7.94 times 10 to the 18th. So comparing them, really everything goes away. It is 10 to the 6th times more powerful. The 6th more energy. And there you have it. Okay, a very similar looking equation is this decibel one. Decibels are a very rare unit in the metric system, where it has a prefix of deci. The kilogram is kind of the standard for mass, but aside from that, most things are just standard is meters. Yes, there are centimeters and decimeters and kilometers and all that stuff, but for us, the standard is decibels. I feel like I missed a good opportunity with my younger daughter. I should have named her Desi with a middle name of Bell, because she is loud. Okay, so again, we're looking at this I over I naught, where that is the faintest audible sound is I naught. So if I make the faintest audible sound, then I is also I naught. And I'm left with 10 times the log of I naught over I naught. Well, that is 10 times the log of 1. The log of 1, we're asking 10 to the what equals 1. Oh, well, 10 to the 0th equals 1. So that is 10 times 0, and that is 0. The faintest audible sound, the sound which below which you would not hear, we would say has a decibel reading of 0. If your parents have an expensive stereo at home, there's a good chance that when you turn up the volume, the number actually gets smaller. And what that's actually telling you is the amount of decibels which it is knocking off of the pure signal. So the fewer decibels you knock off, the louder it gets. If you go up into the positives, it's actually adding and making everything louder. Somewhere in here, I think in this exact room, I have a decibel reader. It's called an SPL device for setting up stereos, making sure that one speaker is as loud as the other. And maybe I will put my daughters to the test on that. Noise on a street measures approximately 75 decibels. How many times as intense is the sound than the faintest audible sound? Again, I'm searching for I over I naught here. So I'm going to say that 75 equals 10 times the log of I over I naught. I over I naught is what I'm looking for. 7.5 equals the log of what I'm looking for. And 10 to the 7.5 is what I have there. I over I naught. And that is my answer. The noise produced in a thunderstorm is approximately 10 to the 11th times as intense as the faintest audible sound. All right, let's find out what those decibels are. That would be equal to 10 times the log of, and they gave me that intensity of 10 to the 11th. Wait a second, the log of 10 to some power is easy. It's just that power. 10 times 11, we're looking at 110 decibels. Technically a lowercase d, uppercase b. And that's pretty loud. I will admit that I have been to rock concerts louder than that, which is probably why I have to ask everyone like 4 times what they said, because I've lost a good amount of hearing. 125 decibels is what's known as the threshold of pain. Anything above that will literally hurt to listen to. If you're into that kind of thing, when Metallica played the first concerts at Ontario Mills, I was there, and my ears were ringing for days. Ministry, Helmet, Sepultura, stupid loud, stupid loud. One of my favorite groups of all times, Grateful Dead, they had what's known as the Wall of Sound, which was best listened to at a distance of about half a mile away. Loud music, what can I tell you? Okay, let's get through some of these pretty easy examples, and we can call it a day. 4 to the negative 2 is, of course, 1 over 4 to the 2. It is 1 over 16. 9 to the 1/2 is really the square root of 9. It is 9 to the 2nd root. It is, of course, equal to 3. 8 to the 4/3, well, I can think of it as the cube root of 8 to the 4th, or I could think of it as 8 to the 4th, all cube rooted. 8 to the 4th sounds like a headache to me. The cube root of 8 isn't so bad, it's 2, and 2 to the 4th is 16. So that seems like the easier way of doing it. Over here, same idea. The cube root of 1,000 is 10. 10 squared is 100, and that negative is going to give me a free trip from the numerator to the denominator. 0.75, well, decimals I really don't know how to do, but we're not out because I can convert the decimal to a fraction. And all of a sudden, that looks kind of familiar. If 8 to the 4/3 is 16, then 16 to the 3/4 should be 8. Just to make sure, the 4th root of 16 is 2, and 2 cubed is 8. 2/3 to the negative 1, well, a negative not only gives you a free trip from the numerator to the denominator, but vice versa. That 3 came up, that 2 went down. 15 to the 0th is 1. I can distribute that, that exponent. Exponents do distribute over multiplication or division, and I get over 8/27. But when you're dividing by a fraction, you're multiplying by the reciprocal. I believe we'll end up with 27 thirds here. I don't know where that thirds came from, 27/8. All right, sorry about that. Solve for y using the rules of exponents. So what I'm going to do here is I'm going to write the left-hand side as 32 to the 2y. And when I multiply, I add these. So this is 2 to the 3 plus y. I could play around with logs, but I don't think I have to yet, because this is really 2 to the 5th. To the 2y. I feel like I'm about to be invaded by my kids again. That is 2 to the 10y, because when you take an exponent to an exponent, you multiply, equals 2 to the 3 plus y. Beforehand, we were able to solve this, but we weren't really able to say how we did it. We just kind of cancel out those 2's. Now we can say, oh, we took the log base 2 of both sides. Triumphant sip of cola, and 10 to the y equals 3 plus y. How about 9y equals 3, and apparently y equals 1/3. Get in there, get in there. The log base 2 of 8, more important than knowing what it is knowing what it means. They're really asking me 2 to what power equals 8, and you can't fool us on that one. 2 to the third equals 8, so there's a 3. 10 to what power would equal 0.0001? Well, 10 to the negative 1 would be 0.1, negative 2, negative 3, and negative 4. 8 to what power would be 1/2? Well, first I'm going to start by saying the log base 8 of 2 is what? Well, if 2 cubed is 8, then 8 to the cube root, or the cube root of 8, I should say, is 2. And to get that, we're going to get it into a fraction, we're going to have to put in a negative sign. So I think my answer here is going to be negative 3. Getting more confusing, 9 to what power is 27? So really they're asking me 9 to the x equals 27. I'm thinking of this as 3 squared to the x equals 3 cubed. 3 to the 2x equals 3 cubed. 2x equals 3, and x equals 3 halves. Here I'm getting 100 to the x equals really 1 over 1,000. 1,000. These are both powers of 10. I could say 10 to the 2x equals 10 to the negative 3. 2x equals negative 3. This time x equals negative 3 halves. Similarly, 3 to what power equals 1 over 81? Well, 3 to the 4th equals positive 81, so 3 to the negative 4th should equal 1/81st. Getting even sneakier, 5n to the x. What am I taking to the x? Oh, all of 5n equals 25n squared. Well, it looks like I squared this thing. X equals 2. And finally, 8 to what power equals 4 root 2? So really 2 cubed to what power equals 2 squared times 2 to the 1/2. 3x equals, my rules say I add 2.5. X equals 2.5 over 3. Nobody likes to see a decimal in a fraction. Why not call it 5/6 and be done? Speaking of being done, so are we. Thank you for joining, and I will see you guys on Monday. See, how do I end this thing? Much